Regarding ray diagram, we have to know some important new terms about lens. What is lens? A transparent material bound by two surfaces of which one or both surfaces are spherical forms a lens. A lens may have two spherical surfaces bulging outwards. Such a lens is called the double convex lens. It is thicker at the middle as compared to the edges. Now optical center, you are watching in the figure that the central point of the lens is called its optical center and it is marked as O. So it's the optical center. Now center of curvature. A convex lens has two spherical surfaces. Each of these surfaces forms a part of a sphere. The centers of these spheres are called centers of curvature of the lens. Since there are two centers of curvature, we may represent them as C1 and C2. Now principal axis. What is principal axis? An imaginary straight line passing through two centers of curvature C1 and C2 of a lens is called principal axis. Now principal focus of a convex lens. When a number of rays parallel to the principal axis fall on a convex lens, then after refraction from the lens, all rays meet at a point on the principal axis. This point is called the principal focus of the convex lens. Now you are watching that all the points meet at F. So here F is the principal focus. Now you have to remember another important things, and that is if you pass parallel rays from the opposite surface of the lens, you get another principal focus on the opposite side. Hence a lens that two principal focus, they are represented by F1 and F2. Now focal length. In this picture you are watching that it's a convex lens where O is optical center and there are two focus F1 and F2. This distance between the optical center of the principal focus of a spherical lens is called the focal length. Now we are watching some positions for a ray diagram F1, F2, 2F1 and 2F2 of the principal axis. By using this position, we have to draw some ray diagrams. That is why we have to abide by some rules. Here, rule number 1 in convex lens. A ray parallel to the principal axis after refraction from the convex lens will pass through the principal focus on the center of the lens. Now rule number 2. A ray passing through principal focus of a convex lens after refraction will emerge parallel to the principal axis. Now you are watching the drawing. A ray passing through principal focus of a convex lens after refraction will emerge parallel to the principal axis. Now rule number 3. A ray passing through optical center of a convex lens will emerge without any deviation. You are watching that a straight line passing from optical center O, so it will emerge without any deviation. Let's study image formation by convex lens. Case number 1, object very far from the lens. We can assume the object is at infinity with reference to the convex lens. In this figure, you are watching that AB is the object that is very far from 2F, that means center of curvature. According to rule number 1, a ray parallel to the principal axis after refraction from the convex lens will pass through the principal focus. Here all points meets at F2. Then what is the characteristics of image in case 1? Nature, real and inverted. Size, point size and position at F2. As the image is formed in front of lens, so it is real and inverted, and size is point sized and position is at F2. So this is the characteristics of image when an object is at the infinity. Now case number 2, when object beyond 2f. According to rule number 1, a ray parallel to the principal axis after refraction from the convex lens will pass through the principal focus on the other side of the lens. And by using rule number 3, a ray passing through the optical center of a convex lens will emerge without any deviation. Both points meet each other between f2 and 2f2. So here is the image. So what is the characteristics of this image? Natural, real and inverted, size diminished, position between f2 and 2f. Look carefully that AB is the object, and after refraction both lines meet together at the same point A prime and B prime, and it is placed between f2 and 2f2. This is the image. And what is the characteristics of image? Natural, real and inverted. Size diminished because actual size AB is larger than the image, so size is diminished, and position between f2 and 2f2. Now rules number 3, object at 2f1, that means center of curvature. According to the first law, a ray parallel to the principal axis after refraction from the convex lens will pass through the principal focus, and another one from optical center meet together at 2f2. So what is the characteristics of this image? Natural is real and inverted, size same size, and position at 2f. Case number 4, when object between 2f2 and f1, that means the object is placed between focus and center of curvature. Then according to the two law, first and second law, we draw two ray diagram, and we are watching that they both are bisect at the in front of 2f2, and the figure is like that. So what is the characteristics of this image? Natural, real and inverted, size enlarged, position beyond 2f2. Now it's time to watch case number 5, when object is at f1, that means focus or main focus. According to the previous rule, we have to draw two ray diagram from this object, and you are watching a special picture here. This image is like that. So what is the characteristics? Because both lines didn't meet each other in front of us, it maybe meet each other at infinity. So what is the characteristics of this image? Natural, real and inverted, position at infinity, and size highly enlarged. Because both rays will meet each other at the infinity and long distance from the main object, so the size will be highly enlarged. And at last, case number 6, object between f1 and O, that means the object between focus and optical center. According to the law of ray diagram, two ray passes from optical center and f2, then they will not meet each other in front of the lens. But if we extend it, then we may get an imaginary image, and it will be absolutely a virtual image because the image is formed behind the lens. So what is the characteristics of this lens? And that is natural, virtual and erect, size enlarged, position on the same side of the lens as the object. Now here is a summary for your justification. You can easily find out the position of the object, position of the image, size of the image, and also nature of the image. It will be very helpful for you. This is the 6 cases of refraction of light. Now what is your duty? You have to practice it several times at home so that you may cut a good figure in the examination. So it's my earnest request to you to practice it properly by using instrument. So draw this picture again and again at your home. If any problem, then ask me. Have a nice day, dear.